here we go. This is obviously about the final type of conic section called hyperbolas. So once again, we have these four basic types, and now we're going to be talking about hyperbolas. And to get us started here, let's point out once again we have standard form, or in this case standard forms. So we're going to have to be able to compare here as we go this version of a hyperbola equation and also this version of a hyperbola equation, you know, with being in this, again, I'm standard form or whatever it's technically called. So here's how it works. Now, if you notice, if you try to like maybe compare it back to, let's say, ellipses, hopefully you notice first and foremost that we have a minus sign instead of a plus sign. And that on the surface seems like the main difference. And yeah, I would agree with that. On the surface, this definitely looks like the biggest, what's the word, like visual cue that what you're probably looking at here is a hyperbola and not, say, an ellipse. So the graph obviously is going to be different. It's going to be a hyperbola. So here's how this works. You could have the x sort of term be your positive term and your y deal, your whole y term looking there, be your minus, or over here it could be vice versa. You could have, you know, your y term be the positive term and you'd be subtracting the x sort of term. No matter what, your a squared, and this is just technicalities, you know, kind of like a formality, a technicality. I wouldn't let it mess you up that much, but I mean, it's kind of a different deal compared with what we were doing with the ellipses. A squared is always with your positive term. So notice how it's always a squared here and b squared here. See here how the a squared is with the y. Again, it's really just a technicality. Your a value will always be, here we go, let's cut to the chase here. Let's start to cut to the chase. Your a value will always be the distance from the center to your vertices. Okay? And once again, h comma k is your center, like it's been since talking about parabolas or circles at least. So this would be like one vertex, and over here this is also, you know, like an a value, kind of like a vertex. Now your b value matters because your a and b values together coming off of the center. So a is especially important because that's where a couple vertices are going to go. But again, your b value also matters because together a and b make this like rectangle, which is not officially technically a part of your graph, just like the center is not going to be like technically an actual part of your graph. But the rectangle here is really important. So boom, boom, makes your rectangle, because these asymptotes go through the corners. You know, like these green asymptotes go through the corners of this rectangle that was made with your a and b values. And again, like your asymptotes like aren't technically a part of your final graph as well, but they're important, okay, because to make your final graph here, coming off of this vertex, it's almost like a parabola that gets sort of drawn using these asymptotes as a guide, you know. So once again, these parabola type shapes kind of creep closer and closer to these asymptotes, okay? So the asymptotes are important when it comes to drawing these hyperbola curves, okay? Now, to kind of get back to the comparison of like this version of a hyperbola versus this version of a hyperbola, when the x term is your positive term, obviously like this would be your a, and your hyperbola is going to be opening right and left. But here, you know, when the y term is with the a, so now your hyperbola is going to be opening up and down. So when your y term is the positive term, you know, oh boy, just kind of a basic sketch, forgive me. This is not great. Oh, that's not good at all. But you get the idea. The hyperbola for this version is going to be opening up and down. And once again, the b value mattered because we wanted to make this rectangle, which dictated where the asymptotes were going to go. And that in turn sort of enclosed, I don't know if that's the proper term or anything, but you know what I'm saying. It kind of gives like these boundaries or these asymptotes where the hyperbola is going to, you know, never touch, but kind of like creep closer and closer to forever. And so that's the basics. What more can I say? I mean, obviously, I see this right here, so I haven't forgotten about that. But what else can I really say? Oh, I know what I was thinking of. I like how almost like years later, like after I was in your shoes or I was in college, years later I learned about just this simple rectangle trick for the asymptotes. But when I was learning all this stuff, it was emphasized how you could actually have equations for these asymptotes, you know, like just linear equations, because you notice how these have a certain slope and this has another slope, you know, probably like an opposite slope perhaps, whatever. My point is, it could definitely be a thing, and we could actually talk about what would the equations of these asymptotes be, because I think there's literally formulas. If I remember when I was in my youth, in my younger days, I remember there were actually like these general, almost like formulas for these asymptotes, these lines. But I'm not going to really emphasize that. I mean, I like how this a value and b value makes this rectangle and how the asymptotes just go through the corners. And also, just like with ellipses, hyperbolas also have these c values, which refer to these focus points. Here it's different. Here c squared equals a squared plus b squared. And what that's going to mean is that our focus points, wherever this would be, I don't even know. It's somewhere, it would be almost like further out from the center than this vertex, you know what I mean? So it's kind of different from ellipses in that way, because that's a plus and not a minus. And again, your actual c value would be the difference from, or the distance from the center to the focus point. That would be c. So, and then wherever that would be, likewise on the other side. Here, you know, wherever it is, you know, your c value would always be kind of like that. But I think that's basically it for the basics. Let's do some examples. See if anything else sort of pops up. Example number 1. As you write this down, again, feel free to pause if I'm going too fast and I accidentally don't give you time to copy stuff down first. You can always, it's a video, you can always pause it. So does this fit the mold of one of these standard forms for a hyperbola? Well, you see the minus, so I mean, I'm thinking, yeah, right? So what would H, I don't know how, if I'm going to, so we should be looking for like what H is, what K is, what A is, and what B is. I don't know if you actually have to write these down. Like I normally don't, but you know, what would H be here? Now remember, H always goes with the X. See here, it's X minus H, but over here, you know, it's X minus H secondary. But again, my point is, H always goes with X. Please don't forget that. So here, H would be here, like X minus what? Well, that means like 0, right? And so K, it's always like Y minus K. Well, so technically, K here is 0. And so that means our center is 0, 0. Again, for your homework, if we're doing distance learning, I don't know if I can actually have you turning in actual sketches of graphs. You know, we'll see. But I can at least ask you for things like the center and everything else I'm going to point out here. So the center is 0, 0 of this hyperbola. My A value, remember, it doesn't matter which one's bigger. It doesn't matter which one goes with X and which one goes with Y. With hyperbolas, your A squared is always with the positive term. So here, 9 is like your A squared. So that means A is 3, and that means B is 4, because B squared is 16. Now, what could I ask you about, I guess? I could ask you about the center, so it helps, you know. What I also might ask you about is the two vertices, the coordinates of the two vertices, okay? Well, since A is 3, all right, and this hyperbola is going to be opening up and down, you know, it's going to be 3 like spaces above the center, but also 3 spaces below the center. And if you have some grid paper, you know, it kind of helps, you know, it kind of helps to maybe like sketch a graph or use some grid paper. But I mean, there's actual formulas that you could apply here, like in this situation, it looks like it's going to be H comma K plus A, but also H comma K minus A. I don't know. I don't think we need to make it that convoluted looking. But there are, like, you could actually generalize formulas for this. But I think, you know, just having a little sketch over here, right, where there's the center. Again, hopefully you can at least sketch some graph paper or something to help you. So there's the center, and so that would be one vertex, and that would be another vertex. So we're talking 0, 3, and 0, -3. You know, my B value is 4, so that means kind of spacing that out. Now again, like, I have this very, again, it's not like technically part, but here's like the rectangle, and so my asymptotes would go like this through the corners. And I suppose I could ask you what are the equations of those asymptotes, but I think I'm going to refrain from that on the homework. We'll see. Be ready for that, just in case. So here's the one vertex. Once again, we're opening up and down. So if I was going to sketch, oh, that's awful. Remember, people, that is so bad. Remember, your hyperbola, it's going to like keep creeping closer and closer to it. You know what I mean? I should do different colors. You know what I mean? Like, so like my final, what color would be good? Just some kind of red. So here's like my final, maybe blue. Oh, God. A little better. So that would be like my final graph. If you wanted to include the asymptotes, which are invisible in their own right, you know what I mean? But I guess in a way, asymptotes are officially a part of like the final graph. What I also might maybe ask you for is the focus points. Remember, the focus points, you find C, and your focus points are that far away from your center. You know what I mean? So my C value, if C squared equals A squared plus B squared, so that's 9. So 9 plus 6. Ooh, this is going to be nice. Because A squared is 9, B squared is 16. So C squared equals 25. So that means C equals 5. That turned out nice. So that means, like, again, this hyperbola opens up and down. So my C value is going to be 5 spaces above the center. 1, 2, 3, 4, 5. And then 5 spaces below the center. So again, like you could make like generalized formulas where, you know, when your hyperbola is opening up and down, you know, you could talk about how, oh, so then the one focus point is going to be H comma K plus C, but also the other one would be H comma K minus C. You know what I mean? Or, you know, you could, that does help. But the bottom line here, let's see, my one focus point is going to be 0 comma 5, and my other focus point is going to be 0 comma negative 5. So I might also ask you for that. Next example. We're only doing like 3 or 4, aren't we? We're only doing 3 examples. Okay, let's go. Okay, first of all, my center here would be what? That would refer to H comma K. Oh, hey, in this case, H is here. Looks like my X, you know, sort of term is the positive term now. So my hyperbola is going to be what? Opening left and right. So my center is, let's see, minus 1. That means H is just 1. And since this says Y plus 2, that actually means my K is negative 2. Hopefully you understand this sort of thing by now. So there's my center. In this case, my A value is 4. So my A value is 4. And again, we're opening like left and right. So I can already sort of say that my vertices would be what? You know, 2, 3, 4. 5 comma negative 2. And negative 3 comma negative 2. Again, like you could generalize this almost as a formula. When you're opening left and right, you could talk about how the one vertex has to be h minus a, comma, negative 2 or comma k. And that would have been this one, you know. This was like 1 minus 4, you know, basically h minus a, comma, k. And this one is technically h plus a, comma, you know. But having the actual graph over here helps. But again, I hope you understand what I mean when I say you could like generalize formulas, so to speak, for these vertices. Now again, that means B is 2, correct? So that means we could, like, if I was actually sketching, you make your rectangle that's there but not there. And then you could sketch, that's a little sketch, you could draw these asymptotes, which again you could have equations for those. And then we could sketch our hyperbola, not bad. And then we could talk about our focus points. So c squared equals 16 plus 4 is 20. So that means c equals the square root of 20. Obviously, it occurs to me that this can be not only estimated to be like 4 point something, but it could also be simplified, which I can't start being a hypocrite now. You should always simplify square roots. So this is actually going to become 2 root 5. So that means that my focus points are going to be, okay, again, you could literally think of this as a formula, because the distance from the center to each focus point is the c value. So this would be very simple if my center was just 0, 0. If you're centered at 0, 0, then your focus points here would just be 2 root 5 comma 0 and negative 2 root 5 comma 0. But again, here you could always generalize it as, again, it's different whether you're opening left and right versus opening up and down. But here you could pretty much say that my one focus point, I'll even write this out one time here, would be h, let's not make it too confusing, plus c comma k, and also h minus c comma k. Okay? And so that would be, literally here, 1 plus 2 root 5. As weird as that, and what's my k? Negative 2. So as weird as this looks, that's your answer. Like, we don't want to approximate, you know, with decimals. So 1 plus 2 root 5 comma negative 2, and also 1 minus 2 root 5 comma negative 2. You know, like wherever that would be. Alrighty. And my last example, here we go, peoples. Me being a nice guy, this is already just like the first two examples. This is in your standard form that we like. So what's my h comma k here? What's my center? It looks like h is technically 0, x minus 0, quantity squared. And then what's my k? Just 3. So 0, comma 3, that's my center. So what's my a value? Well, first of all, what's a squared? Isn't a squared technically 1? So that means a is 1. So I'll jot it down, I guess. A is 1, and b is, if b squared is 25, b is 5. So is this hyperbola going to open left and right or up and down? Should open left and right. So my a value, so there's my two vertices. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So there's my one vertice or vertex. There's my other vertex. Again, I could, come on here. Two, three, four, 5. 1, 2, 3, 4, 5. Okay, looks pretty good. So then we could draw our, oh boy. Asymptotes through the corners. And, come on, pen? And oh my gosh, that is crazy. Oh, jeez. You get the idea. I wouldn't be surprised if my asymptotes got all crooked there. Oh, you shouldn't... See, I shouldn't give you the idea that it starts to curve away. It's only ever going to get closer and closer and closer. It's not going to like curl away from... Oh my god. Nice. So we're doing the focus points. So okay, the vertices. So again, the vertices in this case would technically be, because it's opening left and right, it'd be like h plus or minus a. So oh, well, the good news is it's 0. And again, the graph helps. Like you could just literally say, like, what are those coordinates? But were we talking like positive 1, comma 3 and negative 1, comma 3? Again, this is technically h plus a, and this is h minus a, and it's always comma k. My focus points, so what's my c value? Oh my gosh, come on, active board and pen. C squared equals a squared plus b squared. So we're talking 26. So that means c equals the square root of 26, which does not simplify, I do believe. So my focus points again, as a formula, if the hyperbola is opening left and right, it would always be what? H plus or minus c, comma k. H plus or minus c, comma k. Or if it was like, if it was opening up or down, like let's let me actually go back here, because this would be h, comma k plus or minus c, because now you're adding that c value to the y coordinate of your center. Anyway, again, that's just what I'm talking about with these generalized formulas. So here the focus point, ooh, 0. That's nice. So it's like 0 plus or minus my C value. Again, my C value is root 26. So we're just talking like root 26, comma, what's my K value? 3. 3. And negative root 26, comma, 3. You know, like wherever those are. Okay, and so that's what we're going to, cover for now with hyperbolas.